Did you see that? You you didn't see that? Okay, good. Alrighty. I'm gonna get in trouble for that. Hey folks, has everybody got their Christmas ornament? Their mathematically significant Christmas ornament with them? You better keep that handy because, well, it just makes you feel more festive whatever time of year you're watching this. Or you not give a rip, like me. You're back for lesson 82, and once again, we're doing inequalities. Ah, stab me in the eye. I hate these. I mean, these are really interesting. Let's try it. I love this. Multi-step compound inequalities. What other adjectives could they add to this thing? Oh, goodness gracious. Today we're going to rediscover. We're going to talk about two very simple words here. A two-letter word, or, and a three-letter word, and. If we wanted to, we could write these as like Venn diagrams. Or like this. Something fits into category A, or it fits into category B. But it doesn't fit into more than one category. Whoops. Always stay hydrated. You got this situation. Something's in two categories at the same time. Like, we could have had integers are also whole numbers. Ooh, and there you go. Two categories. Now, we're doing it with compound inequalities. So that means if we have an OR situation, they're going to tell you something like this. X is about less than -1, or X is bigger than 6. How about that? Now, we're not really quite sure what X is, but we know that it's not somewhere in the middle, that there are some boundaries here. So picture of that kind of thing would look like, can't be in my video, your child lost about this. Or we put a number here and we get this type of thing. If I have to hit pause and this thing doesn't work when I start recording again, I'm going to just flip out. Try to do these things in a timely manner, but whatever. Oh my word. Okay. Now I simplified that answer up there to say that's when you get to the end of the problem, you're going to have this or that. You're going to have a picture where the things are going away from each other. They're not overlapping, right? If they were turned around, like we're going to do the next one, they would. Now, this one starts off with 4x minus 7 is less than 3, or 2x minus 19 is greater than -7. So on both of those, it just turns it into two smaller problems that you have to solve and then kind of combine those answers. Look at how they overlap or they don't overlap. So this one ends up, I don't know, maybe this isn't this one right here, because I'd add 7, 4x is less than 10, duh, x less than 2.5, okay? Or add 19, 2x, and 12. Oh, snap. I think I just wrote this down wrong. X greater than 6. Okay, so there we go. We'd have something where we got two things and we got to put them on the same number line. What did I do wrong there? I wrote that thing down. 4x minus 7 greater than 3. Added 7 to both sides. That's probably supposed to be a negative. Yeah, there you go. So that would end up being 4, and then I'd have myself something nice like -1, or 4. Okay, 4. Say it. 4. Did you say it? So I said to say it just now. Like, well, right, not now, but you know what I mean, like 5 seconds ago. 4. And let's show you an and. Okay, here's an and. Blah 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 blah. Put that on Google Translate. Here's the messy part because you got this all in the middle between this thing and that thing, which means actually here's one problem. Cover over the inequality on this side, and then I could cover the over the inequality on this side, and I have a separate. Here we go. So you could split this up into two problems if you wanted to. Don't come in here. Hey. By working the math in the middle here, I'm going to clean this up, and this is going to be 6. So 5. 5 is late in the day. 5x minus 4. Okay. At this point, you could say I've got the inequality. I got that one, and I've got 5x minus 4 less than or equal to 11. I can split it up like that and work each of those separately, which might be safe, might feel good, might feel a little, I'm not so sure about doing all that math at once. So if you want to do that, then yeah, you can add 4 here. The negative 5 has to be less than or equal to 5x. This looks nice. Divide by 5, get negative 1. And then over here, you can add 4. 5x has got to be less than or equal to 15, so x has to be less than or equal to 5. You get to that point, and now you can draw these two things in there. Okay, so x has to be greater than or equal to negative 1. Okay, and then the arrow goes this way. Or x is less than or equal to 5, and now we're looking at this way. And that would keep going that way, and that would keep going that way, but we're only worried about where they're both true, that this and that are true, which means we got to cut off the stems here and just look at the places where they crisscross. Right in here, between those two numbers. Between them. Here I say. Now, I could go back here with this problem and just tweak it a little bit and do it all at once. Now would be, whatever I do to one piece, I have to do to every piece. So I could do this all in one kind of fell. So I'm going to add 4 to everything. That keeps everything still balanced. And that makes this side negative 5. The middle part's just 5x. And over here I've got 15. So it's the same thing that I had when I did it in separate pieces. And then I can divide every piece by 5. And I get the same thing. I'll get the expression negative 1 must be less than or equal to x, which must be less than or equal to 3. Did I get it wrong the first time? Probably. All right. I get this, which is expressed as that. It's where x is between these two. So you might think of and as between as well, or those two things where they overlap. There may be some simplification first, like we just had in that one. We had to simplify the middle portion first before we could go on. But it's all the same skills that you already know, just adding this extra thing, and it looks a little bit different. But again, remember, you get here and you can split it up. That's a problem. Cover that part, it's a problem. Or you could do it all at once and prove to yourself that how awesome you are. You don't even need a sticker for that, right? Last thing I want to look at is example 3. I think they write it in a very interesting way, or they're using a creative method to do this. And the application is with a zoologist. The zoologist randomly chooses 5 zebras out of a herd of 20 zebras. 4 of the zebras weigh 540, 550, 520, and 530 pounds respectively. These are fat zebras. No offense if you're a zebra out there watching this. What could the weight of the 5th zebra be? The average weight of all 5 zebras is to be between 500 and 600 pounds. be in between the two, right? Stay away. Don't get out of my video. I have to stop it again. This is the law. Here's where we put our little equation. There's our 540. There's that Bertha and Charlie and Zelda and Mark and the one that we're going to add into it. And when we put all those zebras in together, then we've got 5 zebras. We're going to take the average. Adding that last one, we have to keep the average between 500 and 600. So if we get a zebra that's this obese, just really sick and obese, we're gonna have to, it's not gonna work, right? So we got to keep our numbers within a certain range. Now, what do we do to solve this whole thing? We want to solve for x here, right? But we got this stupid fraction here, so let's multiply everything by 5. Angry bird. Okay, 500 times 5, 2,500. And then we've got this sum of zebras, etc. Times 5, that goes away, and then we've got 600 times 5, blah, 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 blah. That made the problem way easier, and now it looks like an and problem, right? We're going to add up all the zebras here. 1, 2, 3, 4. That's 2,090, 2,110, 2,140 pounds of zebras. Where we got to just take that off of both lists, this 2140 business, both sides. Okay, let's do it. This makes this one 360. There's our answer. And over here we got 860. So our extra zebra needs to be between a slender 360 pounds and a fairly sizable 860 pounds. And it can be in between. There you go. And or, your new things, your new concepts. Enjoy your own zebra. Okay, I did wear something with stripes today just for you. I want you to know how much I care. And long live the zebra population of America and the world and the universe. God bless America.